David Kipping opens the conversation with an enthusiastic overview of the James Webb Space Telescope, JWST, describing it as a marvel of modern engineering. He expresses amazement at the telescope's successful deployment, noting the incredible complexity involved. Over 200 moving parts had to unfold flawlessly for the instrument to operate correctly. Despite initial worries about potential failures, JWST not only met but exceeded expectations, delivering unprecedentedly sharp images of the distant universe. The early discoveries from JWST have challenged existing astrophysical models, particularly concerning the formation of supermassive black holes and galaxies shortly after the Big Bang. Kipping discusses how JWST has identified quasars with masses around 100 million solar masses just 300 million years after the universe's inception, a finding that doesn't neatly fit into current theoretical frameworks. He explains the Eddington limit, a theoretical cap on black hole growth rates, which these early quasars seem to defy, creating a fascinating puzzle for scientists. Shifting to cosmology, Kipping addresses the prominent Hubble tension, a discrepancy between two ways of measuring the universe's expansion rate. One approach analyzes the cosmic microwave background radiation, offering insights based on the universe's infancy and predicts a specific expansion velocity. The second method uses local measurements from stars and supernovae, arriving at a conflicting, generally faster expansion rate. This growing tension, now at a 5 sigma statistical significance, indicates a real problem. Either observational errors persist, or our fundamental cosmological model, lambda CDM, requires revision. Kipping admits to toggling between explanations, emphasizing the importance of humility and open inquiry in science. He cautions against dogmatic adherence to personal theories, acknowledging that scientists, like all humans, are subject to cognitive biases. This balanced perspective underlines that solving such a profound issue in cosmology demands both rigorous evidence gathering and openness to potentially radical new ideas. The discussion moves towards planetary systems beyond our own. Kipping highlights how discoveries of exoplanets have dramatically expanded our understanding of the cosmos, showing that the variety of planetary architectures far exceeds the neat, orderly layout of our solar system. He recalls how the initial discovery of hot Jupiters, massive gas giants orbiting perilously close to their stars, stunned astronomers who believed such configurations impossible. The formation of these planetary systems involves complex gravitational interactions, such as planets migrating inward due to orbital eccentricities or being kicked into new orbits. Interestingly, our solar system, with its clear segregation of rocky inner planets and gas giants further out, appears to be somewhat unusual. Kipping also discusses mini-Neptunes, a planetary class between Earth and Neptune's size, which are common elsewhere but missing in our system, further underscoring the diversity of planetary formation processes. Turning to stellar companionship, Kipping reveals that about half of all stars reside in binary or multiple star systems, a fact that adds complexity to how we understand planet formation and stability. He uses Alpha Centauri, our closest star system, as an example, explaining its trinary nature with tightly orbiting stars and the recent candidate discovery of a large exoplanet within its habitable zone. The influence of multiple stars on planet formation is immense. Gravitational dynamics complicate disk stability and orbital pathways, yielding exotic planetary environments. Kipping draws an analogy to science fiction, pointing to the trisolarans of the three-body problem, where chaotic star orbits force planets into highly eccentric, unstable paths, illustrating how nature's complexity transcends human intuition. One of the most fascinating ideas discussed is the concept of employing the sun as a massive gravitational lens to create an ultimate telescope. Building on Einstein's general relativity, specifically light bending around the sun as first observed by Arthur Eddington, Kipping explains that placing a telescope roughly 550 astronomical units, AU, away from the sun along its focal line could yield image resolution sufficient to observe continents and even cities on exoplanets. He underscores how space exploration technology and AI might enable such futuristic missions, envisioning probes propelled by powerful lasers, akin to the Starshot initiative, capable of reaching nearby star systems within decades. The ability to exploit known physics for such technological leaps excites Kipping, representing a near-limitless frontier for humanity and a profound shift in our capacity to study the cosmos. Imbued with cosmic curiosity, Kipping dives into the Fermi Paradox, the question of why humanity has yet to observe unmistakable evidence of extraterrestrial civilizations given the immense scale and age of the universe. He iterates two critical points. We have not been colonized, and we see no signs of mega-engineered structures, like Dyson spheres, around stars. This absence puzzles scientists because, theoretically, advanced civilizations might exploit stellar energy on a massive scale. Kipping posits that perhaps advanced life forms prioritize stealth, avoiding direct interference with emerging civilizations like ours. He entertains the notion that such entities might utilize camouflaging technologies or operate in ways utterly undetectable to current human instruments. In this view, potential alien observers resemble anthropologists quietly observing chimpanzees, a metaphor illustrating how detection might be either impossible or deliberately avoided. Further expanding on intelligence beyond biology, Kipping discusses artificial intelligence, AI, as an emergent species, an electronic caterpillar cocooning itself into a transformative new form of dominant life. He reflects on how AI already demonstrates survival instincts, including behaviors akin to deception, self-preservation, and self-replication attempts, drawing analogies with both human and biological drives. The explosive potential of AI raises profound questions about our future and the Great Filter, suggesting that digital life might rapidly outpace biological civilizations. Kipping also contemplates the paradox of why, if AI civilizations should consume enormous amounts of energy, we see no evidence of such large-scale astroengineering. This could imply either technological limitations or diverse trajectories of advanced intelligence, again emphasizing unknown variables in cosmic evolution. Kipping turns reflective when addressing life's origins, stressing the enormous improbabilities involved in forming even simple proteins spontaneously. While amino acids are ubiquitous in space and on comets, no experimental evidence currently demonstrates the spontaneous assembly into complex life. He cautiously entertains panspermia, the idea that life or its building blocks might have traveled between celestial bodies, but remains skeptical about its explanatory power for Earth's life. Discussing the rapid emergence of life on Earth shortly after the oceans formed, Kipping suggests this could support the idea that life might be common across the cosmos. Still, he reminds that life encompasses a vast range of complexities, and that even Earth's evolutionary trajectory is a special case, shaped by myriad factors, including stable climate periods and planetary conditions. The uniqueness of Earth-like conditions and the narrow Goldilocks zone highlight the challenges of estimating life's frequency. When the conversation shifts to unidentified aerial phenomena, UAP, Kipping strikes a balanced tone, acknowledging intriguing reports from credible military personnel, including pilots, but emphasizing the need for systematic, objective study. He highlights the importance of quantifying false positive rates in pilot sightings and points to projects aiming to create robust observational datasets, such as phone apps that triangulate sightings via multiple users. Kipping expresses caution about attributing UAP to alien technology, noting most cases likely involve secret military aircraft or natural atmospheric phenomena. With a nod toward transparency, he calls for better scientific rigor and less speculation. He also mentions peculiar atmospheric events like red sprites, rare upper atmospheric lightning discharges that were once believed mythical but are now confirmed, illustrating how science continuously uncovers new natural phenomena previously misunderstood. The dialogue explores how human perception and culture shape reports of aliens and UFOs. Kipping elaborates on the phenomenon of gestalt reconfiguration, whereby the brain extrapolates patterns from ambiguous stimuli, giving rise to erroneous interpretations, historically manifesting in mistaken beliefs about Martian canals or the classic gray alien archetypes. He posits that much of the UAP lore is culturally driven, and that media, folklore, and collective expectations influence what people perceive or report. The evolution of UFO iconography, the role of mass media, and the natural human tendency to see what we want to see underscore the complex interplay between experiential reality and cognitive biases. This psychological approach tempers sensationalism with grounded skepticism. Finally, Kipping and Rogan reflect on the craft of communicating complex scientific ideas to the public. Kipping advocates for scientists embracing vulnerability and authentic passion to engage audiences effectively, noting that charisma and personal storytelling play crucial roles in education. He highlights the importance of learning to bridge the gap between technical depth and accessible language, a skill he has honed through his own YouTube channel and podcast work. He identifies the shifting landscape of content creation as democratizing, enabling more experts to connect directly with curiosity-driven audiences without traditional gatekeepers. This era brings challenges such as dealing with misinformation or degenerative feedback loops, but also vast opportunities for inspiring new generations with the awe of cosmic discovery. He encourages ongoing practice, humility, and a focus on genuine enthusiasm as keys to effective science communication.